This is the solution video for section 8.2, problem number 27. All right, so for 27, it says set up an integral that represents the volume generated when the region bounded by y equals x squared plus 1, x equals 0, x equals 2, y equals 0 is rotated about. And then for A, it's x equals 3, and for B, it's x equals negative 1. All right, so let's start off with this graph, y equals x squared plus 1. So the basic parabola that has been shifted 1 unit up. So we've got this graph. All right, y equals x squared plus 1. X equals 0. Remember, that is the vertical line, the y-axis. X equals 2, vertical line at 2. And then y equals 0 is the horizontal line, the x-axis. All right, and so here is our region. All right. So now we want to think about, first of all, let's go around x equals 3. So x equals 3 is a vertical line over here. All right. And so what do we want to do? Well, I want to use a dx rectangle. Why is that? Well, I want to use a dx because no matter where you move the dx, the upper boundary is going to be this curve and the lower boundary is going to be this axis. However, if you used a dy, then the left-hand boundary would change. And so you don't want to use a dy. It's still doable, but you would need multiple integrals. All right, so I'm going to use a dx. All right, so now the dx is parallel to the line x equals 3, and so that means we're going to use the shell method, right? So shells. All right, so I'm going to have 2 pi times the integral of radius times height, and then with respect to x in this case. All right, so now the radius, remember, how far is the dx from the axis of rotation? So remember, the dx is x units from the y-axis. 3 is 3 units from the y-axis. So what's the difference? Well, it would be 3 minus x. We take the right-hand thing minus the x. So 3 minus x would be the radius. All right, height is always upper boundary minus lower boundary. So the upper boundary is x squared plus 1 minus the lower boundary, which would just be 0. So of course, dropping the 0 would make this thing more simple. All right, and then we're integrating with respect to x, so that means we're integrating from left to right, and so that would be from 0 to 2. And so we would probably just rewrite this as integral from 0 to 2 of 3 minus x times x squared plus 1 with respect to x. All right, and so that is 27a. All right, and then 27b now. All right, so for b, we are moving the line to x equals negative 1, which is over here. All right, and so now we're still using the shell method. So still 2 pi times the integral of radius times height with respect to x. All right, and so now the radius, well, remember, okay, the dx rectangle is still x units away from the y-axis, but now we have this distance, right, which is a distance of 1. Right now, the way we think about this is we take x and subtract the axis of rotation, which is negative 1. So that would be like x plus 1. All right. Then still the upper boundary minus the lower boundary, x squared plus 1 minus 0, of course, right? But you can just not write that. All right, and then we're still integrating from the left-hand part of the region to the right-hand part of the region, so 0 to 2. And so we would write 2 pi times the integral from 0 to 2 of x plus 1, and then times x squared plus 1, and then with respect to x. All right, so that is problem number 27.